Investigating the scientific method with Max Axiom, super scientist. Section 1, A World of Questions. Inside his high-tech laboratory, super scientist Max Axiom receives an important video message.
Beep. Hello, Max. Mayor Richardson here. As you know, the rainy season nears and the city's river is expected to flood once again. To avoid another flood, we need to construct an earthen levee. This barrier wall must prevent water from seeping into the city. The levee must be built from local materials. We need you to study which material is best for defense from flooding. The people need your help, Max Axiom. The city is counting on you.
Sounds like a big problem. Luckily, scientists have a process for solving problems and answering questions. This process is known as the scientific method and often has a few basic steps. Steps of a scientific method. Ask a question, gather information, form a hypothesis, design an experiment, collect data, analyze data and draw conclusions, communicate results. The order or number of these steps can always change, but scientists often rely on these basic methods to organize information. Come on, I'll take you through a scientific way to find answers. Definition. Definition of a levee. A levee is a bank built up near a river to prevent flooding. Or I'm getting it's down here, all right? Levee, a bank built up near a river to prevent flooding. Asking a question is the first step in the scientific method. Sometimes scientists begin with an assigned problem. Other times, choosing a question can be a task in itself. Fortunately, the world is full of questions to choose from. Does the number of boats affect pollution in the river? Why is the sky blue? Why do birds fly south for the winter? How much weight can a bridge support? With so many options, choosing one can seem impossible, but following a few quick tips can make this decision much easier. First, choose a topic that interests you. Scientists work in many fields. Plants, weather, animals, and even video games are great science topics to investigate. After choosing a topic, form a question. Questions that can be answered yes or no don't require much research. Instead, form an open-ended question that can be answered with a thoughtful statement. Yes or no question. Do most birds fly? Open-ended question. Why do birds fly south for the winter? Also, consider the amount of time available and the cost involved. Studying the effects of acid rain on a copper fountain could take weeks. Instead, start with the question, how does lemon juice affect the copper penny? The results might surprise you. After forming a question, the next step is gathering information on the topic. The library is a great place for me to learn about levees and local materials. It has books, magazines, newspapers, the internet.
And don't forget about the librarian, Max.
Of course not, Mrs. Vargas. Librarians are great resources for finding the information you need.
The amount of information seems overwhelming. So take notes and record the book, article, or website where you found the information.
Yes, getting through the maze of information once is difficult. Finding your way back could be impossible. The internet. With more than 100 million websites, the internet is an information gold mine. But even gold miners dig through a lot of rubble to find a shiny nugget. Fortunately, one word can guide anyone toward the riches of the internet. Net. N for note. Note the date. Is the information current? E. Evaluate the source. Is the website reliable? T. Track the information. Does the website say where the information came from? After research, scientists dig into the next step of the scientific method. They form a hypothesis. Hypotheses sound like a complicated term. Really, it's nothing more than a prediction based on evidence. And with a solid understanding of the topic, writing a statement to answer the original question should be no sweat. For example, I've learned the local materials for building a levee include soil, rock, and clay. From the information I gathered, I predict that clay is the best barrier against water leaking. A hypothesis doesn't change during an experiment, so write it down. Hypothesis. Clay will hold back more water than soil or rock. This record helps maintain a clear direction during the project. And don't worry about the hypothesis being correct. The main purpose of an experiment is to show whether the data you collect supports the hypothesis. With a solid question, information, and a hypothesis, the experiment is about to really take off. Welcome aboard, Max. Looks like variable wins for the flight. We should arrive in 30 minutes. Thanks, Sam. That's just enough time to begin the next step. With the hypothesis, I'm ready to make a plan and design the experiment. But first, Sam has reminded me of a key part of any science project. To build an experiment, scientists must understand these variables. Access granted. When Sam described the winds as variable, he meant they are changing. The independent variable of an experiment are parts the scientist changes to test the hypothesis. In this experiment, the materials used to build a levee are independent variables. I'll test each material to find out which holds back the most water. Independent variables: soil, rock, clay. Controlled variables are parts of an experiment that stay the same. Changing one part could affect the results of the experiment. By maintaining the controllable variables, I can be sure the dependent variable is accurate. Controlled variables: temperature of water, height of levee, thickness of levee, position of levee. The dependent variables is what you measure as a result of changing the independent variable. In my experiment, the amount of water that leaks through each material is the dependent variable. We are approaching the drop zone, Max. Identifying variables is only one part of setting up an experiment. The plan for an experiment is called a procedure. Many scientists use a procedure to design their own experiments. Even scientists at Aquarius, the world's only undersea laboratory, uses procedures to study the ocean and coral reefs. Hey, Amar, how's life under the sea? Hey, Max, the ocean always changes. The aquanaut's work is never done. Today, I'm researching the effect of waves on coral reef health. Sounds complicated. A detailed procedure must be useful in your work. Oh yes, I know the variables. Now I'm writing a plan which includes a materials list, dates and times, and exact instructions. The information along with any diagrams will help guide me through the project. It also helps others reproduce the experiment in the future. Thanks for the tour of Aquarius, Amar, but I better get going before the city is underwater as well. More about Aquarius. Aquarius is located 63 feet, 19 meters beneath the ocean surface in the Florida Keys National Marine Sanctuary. Aquarius allows scientists to stay underwater for an extended period of time. The extra time allows longer research, including coral reef monitoring and NASA equipment testing. Section 3. Conducting the experiment. Ask a question. Check. Gather information. Check. Develop a hypothesis. Check. Design an experiment. Check. With all the preparations complete, I'm ready to perform the test and gather information. Remember, keep the trials as similar as possible. I'd even check the water temperature. And this water will represent the city's river. Everything remains the same except for the levee material, which is the independent variable being tested. Wow, the soil is quickly crumbling, but the clay levee still holds. The rocks are strong too, but water easily leaks through the cracks. Measure the dependent variable of water leaking through the levees. Also, record the observations by taking notes, keeping a journal, and even snapping a few pictures. Oops, sorry, Mini Mayor. The information gathered is known as data. Scientists use data to draw conclusions about an experiment, but piles and piles of raw data are nearly as useless as no data at all. Raw data needs to be analyzed to make the information helpful. Charts and graphs are great tools for completing this step of the scientific method. Line graphs show the interaction between two pieces of information. The line graph explains the water lost through each levee over time. When scientists need a graph to show value quickly, they create a bar graph. A bar graph illustrates the total water lost through each levee. Amazing! the rock levee lost nearly all of its contents. Not every type of chart or graph is needed for every project. Pie charts are great for showing parts of a whole, but they aren't necessary for this experiment. Mean, median, and mode. Averages help analyze numbers, and you can identify an average in 3 different ways. For example, let's find the average for the numbers 2, 4, 8, 4, and 7 using all 3 methods. Mean. The point between 2 experiments to find the mean by adding the numbers 2, 4, 8, 4, and 7 and divide by 5. Mean equals 5. Median. The middle number in a lowest to highest set. The median in the set 2, 4, 4, 7, and 8 is 4. Mode. The number seen most in a set. The mode of 2, 4, 8, 4, 7 is 4. The clock is ticking and the mayor expects results soon. But analyzing the information isn't enough. Scientists study the trends of their data to develop a final conclusion. A conclusion explains whether or not the original hypothesis was correct. In this case, the data clearly shows that clay allows the least amount of water to escape. The original hypothesis was correct. Sometimes a hypothesis is false. Even a false hypothesis can teach scientists about what works and what doesn't. Either way, the conclusion to a science experiment should be recorded. The clay levee held back more water than rock or soil. Wow. If there's time, scientists double-check the accuracy of the conclusion by repeating the experiment. The mayor, however, wants these results as soon as possible, and I'm prepared to share and present these findings, which is another important part of the scientific method. Section 4. Sharing the findings. All scientists communicate their results. Sharing data helps people learn from the experiment and possibly repeat the test for themselves. Some scientists publish a report of their findings. A project report is a clearly written account of the experiment. Others present their report to teachers, students, or judges as part of a larger display. The rules for building a science project display aren't always the same. Most displays, however, do share a few common traits. Data, like tables, graphs, and charts. Journal, personal detailed account of the experiment. Abstract, short summary of the experiment's key points. Model, a miniature or small copy of an object. When presenting, also be ready to answer questions from the audience. The rules for building a science project display aren't always the same. Most displays, however, do share a few common traits. Data, like tables, graphs, and charts. Abstract, a short summary of the experiment's key points. A journal, a personal detailed account of the experiment. And model, miniature or small copy of an object. When presenting, also be ready to answer questions from the audience. Yes, Mrs. Mayor.
You've done it again, Max Axiom. What's your secret to unraveling these mysteries?
As you can see, Mrs. Mayor, the scientific method isn't a secret. It's a step-by-step plan for organizing information and solving questions about the world.
Well done. With these findings, the safety of the city can be restored.
Of course, experiments don't always end when a hypothesis has been tested and the results have been shared. Scientists often perform an experiment thousands of times. They test and retest results before accepting the conclusion. The results of an experiment can also unlock another world of questions. What's a theory? A theory explains why something happens. After many experiments and observations, most scientists believe the universe began with a single gigantic explosion. This idea is known as the Big Bang Theory. Although the Big Bang cannot be proven, strong evidence makes this theory hard to argue. Although clay made the best levee, it still seeped a small amount of water. Why? Could rock and clay together provide even greater strength? Fortunately, with the scientific method as a guide, these questions can be answered as well. But remember, the steps of the scientific method aren't strict rules. They are a guide to conducting scientific research. Each experiment is different, and each experiment requires a slightly different approach. Still, the scientific method can be a place to begin any investigation.
Hello, Max. Mayor Richardson here again. Looks like we have another problem on our hands.
No matter how bizarre,